Hello everybody, welcome back to another episode of Coding with Colt. Today is a great day to learn how to code. If you haven't already, I would really appreciate it if you just took a moment to hit the subscribe button down below. It really helps the channel out. My channel is all about, well, coding tutorials for the most part. A lot of them focusing on Python, but I'll cover a lot of other languages throughout the life of the channel. Today I want to talk about what I think is one of the single most important or most powerful aspects of Python, and that's Python lists. Lists are, well, exactly what they sound like. It's a list of data. If you're familiar with arrays in other languages, Python lists have a lot of stuff in common with Python arrays. Let's get started. I'm using a Raspberry Pi here, and in fact, if you're new to coding, I absolutely love the Raspberry Pi and learning to code, especially when it comes to Python, just simply because everything's set up for you. It's pretty much ready to go right out of the box. A little bit of setup to do, but for the most part, not too bad. So the first thing we need to do is we need to start up Python. And what I'm going to do is I'm going to start up a terminal. And it doesn't matter what platform you're on, whether it's Windows or Mac or a Linux system. You're going to start up a terminal window. And the first thing we've got to do is we've got to figure out what command we have to use to start up Python 3. We're looking for Python 3. So what I'm going to do is I'm going to try typing in Python 3 to start. If I can type. There we go. Python 3. And you'll notice for me, it started, and it actually started Python 3. That's what the 3.7.3 means. Now, your number might be a little bit different. It might be, 3.8.4, or even 3.9.0. The important part is that it's Python 3 point something. The other command you might be able to use to start up Python is just plain Python. However, like on my system, I have Python 2 and Python 3 installed. And so when I type in Python, it starts up Python 2.7.6. In other words, Python 2. And that's not what we want. Everything we're going to do is applicable to Python 3. So you want to make sure that it starts Python 3. So if one of these two commands does not start Python 3, you're going to want to install Python 3. I've got some videos in the channel that tell you how to do that. So if you don't have Python 3 installed, go ahead and find that video and install Python 3. Okay, let me go back here and start Python 3. All right. So lists are a lot like, well, let me just talk about variables to start. So you're probably familiar with variables, at least I hope so. Like we could set a variable called x and set it equal to 7. And so this variable x now contains the number 7. I could change it. I could say x equals 10. And so x now holds the number 10. I could even do some math operations with it. I can say x equals x plus, 9. And so now when I print out the value of x, it's 19. Oh, by the way, I wanted to say something really quick about what's called the REPL. So what I'm in right now is called the Python REPL, the read, evaluate, print loop. I don't always like showing things in the REPL, especially to new users or new programmers in Python, and new programmers especially, because they get a little bit confused. And they think that this REPL, when we type in Python, we get this right here, that this is where we write all of our Python code. And that's not exactly true. The REPL is good for, trying stuff out, typing in some short stuff, and it's really, really, really good for learning. But in reality, when we go to actually write a long Python program, we're going to do it in a text editor like I've got right here. I'm going to show you this later. Because everything that I show you in this REPL, we're actually going to implement, or most of what I show you, in a little example program later on. So this REPL is really good for, trying things out and showing things off. But in reality, when we go to write a program, we're going to use those same commands. Okay, we're going to use those same statements. We're just going to put them into a much longer program. Okay. So going back to this. So x holds the value of 19 now. Now here's the thing though. Well, let's try this. So I've created another variable called greet, and I set it equal to hello world. So now this variable here, greet, holds the string value, okay, of hello world. And once again, I can print it out, hello world. And the thing that you need to understand is that these variables pretty much only hold one piece of data. Okay, the variable x can only hold the value, one value. In this case, it holds the value of 19. Before it held the value 10, and then before it held the value 7. But essentially, it's just one thing, one piece of information. Same thing with greet. Now greet's a little bit different because it holds a bunch of letters, but in reality, it's one piece of information. This string hello world. What a list does is it holds exactly that, a whole list of separate data. And the really powerful thing about Python list is that it can hold a mixture of data. Some of that data could be integers, some of it could be floating point numbers, some could be string values. It can hold just about any type of data in it. And it's just a list. For example, if I was going to a grocery store, I might carry a list with me. And that list would have all the stuff that I needed to buy at the grocery store. And so that's going to be our contrived example. So let's start. Let's start on how would we create a list. And there's two ways that we can create an empty list, or excuse me, a list in Python. The first way, and I'm going to create a list. I'm going to call it groceries. And this name is essentially a variable name. It has all the same naming rules as a Python variable. And I say groceries equals, and this open and close bracket. That creates an empty list. So now groceries, I'll show you. TYPE type groceries. So you can see that groceries is of type list. It's a list, but it doesn't have anything in it. Okay, there's nothing in it, no information yet. I'll show you how to put that information in just a few minutes. Okay, another way to start a list is we basically give it information to start. So if it's a grocery list, I might need some milk, some eggs, milk, eggs, bread. I don't know, a hamburger. There we go. All right. So now I've made a list. We've called it groceries. And once again, it's just a variable. It just holds this information right here. That's all. And I can... There we go. It prints it out for us. Milk, eggs, bread, and hamburger. Now, if you want to print out a list, there's a few different ways to do it. In the REPL, just give it its name. But if it's in an actual Python script, as I'll show you in just a minute, you'd actually have to use print. And there we go. We get pretty much the same thing. Whoops. Okay. So now we know how to create list. We can either create an empty list, or we can create a list. This is how we create an empty list right here. Or we can create a list and give it some initial values. So the first thing I want to talk about is how to get to those individual values. So we've got this grocery list has the word milk, the word eggs, the word bread, and the word hamburger in it. And the way that we get to it, and by the way, just in case you don't know, when you're in the REPL, you can press the up and down arrow keys to access the last commands that you entered. So to make it easy, I just scroll up here to groceries. All right. Python accesses these by indexes. What I mean by that is this right here, the very first value in our list is an index 0. Then this is an index 1, index 2, and index 3. And we can get to it, each one, by putting the index value and inside of brackets. So groceries 0 is equal to milk. Groceries 1 is equal to eggs. Groceries 2 is equal to bread. And finally, groceries 3 is equal to hamburger. Now, one thing to remember, once again, is that Python is 0-based. So the very first, element number 1 in the list is actually in index 0. And element number 2 in the list is index 1, and then 2, and then 3, etc. So although this list has 4 items in it, the highest numbered item is in index 3. And by the way, we can get the length of a list. Length groceries. That's going to tell us that it has it's a list of 4 elements. And once again, though, the highest index in this list is going to be 3, because it's going to be 0, 1, 2, 3. Okay. Next thing I want to talk about is modifying the list, and I'm going to talk about adding. Wait a minute. Be very, very careful when you're using the list index, because if you try to access something that's outside the highest value, the length of the list, you're going to get an error, and it's a index error. List index out of range. Okay, now let's talk about adding to a list and modifying stuff inside the list. There's a few different ways you can do that. The very first thing that you could do is you could literally just reassign. So let's print out our list. All right, milk, eggs, bread, hamburger. So I could do something like groceries 2 equals hot dog buns. Okay, now watch what happens. So I made groceries 2 equal to hot dog buns, but when I print out groceries, notice bread isn't there anymore. I destroyed what was in index number 2. Okay, if we look up here, this has the original list. 0, 1, 2 had bread in it. But then I said, hey, make groceries in the second index slot, make it equal to hot dog buns. And that's exactly what happened. We got milk 0, eggs 1, hot dog buns 2, and then hamburger 3. That might not be what I wanted. So there's a few different ways I can add to a list without destroying, without destroying. I have my notes on my phone, so I'm trying to follow a little bit of a, not a script, but at least a semi-organized way of doing this. So there's a few different ways that we can add items to the list, okay, without destroying what's there. Number 1 is append. So I can do groceries.append. Groceries.append. And inside of parentheses, I'm going to put the data that I want to append, and it's going to put it at the end of the list. So maybe I want to put bread back in there. Did I spell bread right? All right. There we go. So now when I print out groceries, I've got everything in there. The other way I could do this is with insert. So once again, it's the list name dot insert, and it takes 2 pieces of data. Number 1 is the index place I want to put it. So let's put it in, I don't know, index 2. I'm just making something up. And what are we going to put in there? Well, we're probably going to need hot dogs, right? And now let's print out the list. So you notice that index 0, index 1, index 2, right there it is. Hot dogs. And then everything else got shifted to the right. That's the probably the 2 most common ways of adding items to a list. And there's 2 other ways I want to talk about real quick. Let's say you've got 2 lists. So let's make a new list. Other groceries. Other groceries equals, and I don't know what we're going to put in here. Coke. What else do we need? I don't know. Flour. That's good enough right there. Okay. There's 2 ways I could add this other grocery list to our original grocery list. The first way is I could do something like this. Groceries equals groceries. I can't spell today. Groceries equals groceries plus other groceries. Okay. So there we go. So now groceries is equal to whatever was in groceries plus whatever was in other groceries. So let's just print out groceries. And there we go. It's now got milk, eggs, hot dogs, hot dog buns, hamburger, bread, Coke, and flour in it. There's another way that I could have done this. So let me make other groceries. Let's put some more stuff in other groceries, some different stuff. Oh my gosh, I'm running out of stuff. Let's go with vegetables. I don't know what else we want. Mac and cheese. This is getting out of hand here. Okay. So now other groceries. Other groceries. I'm just going to print it out to show you. Other groceries is equal to vegetables and mac and cheese. So I could use the plus to add them together. But another thing I could do is my list, groceries, dot extend. And all I pass to it is the name of another list or a list of values, either one. And so I'm going to pass to it other groceries. And now when I print out groceries, there we go. So it's got vegetables and mac and cheese added to it. Our grocery list is getting quite long here. So we're going to talk about here in just a minute removing items from the list. Let me talk about sorting. Let's say we wanted this in alphabetical order. It's just the name of the list, groceries dot sort. And there we go. Let's print out groceries. So now you'll notice it's in alphabetical order. Bread, Coke, eggs, flour, hamburger, hot dog buns, hot dogs, mac and cheese, milk, and vegetables. All right. Let's see. Anything else I want to talk about before? Oh, here's something really kind of interesting. Every now and then you want to reverse the list. And it's just the list name and reverse. And so here we go. You'll see it's now reversed. And I could do it again, and it will reverse it yet again. There we go. So list dot reverse, or the list name dot reverse if you want to reverse the list. Okay, so let's talk about removing things real quick. There's a few different ways that we can use to remove items from the list. The first thing is we can do, let's say we want to remove T-R-O-C-R. I want to remove flour. All you gotta do is put the name of the or the element you want to remove, and it's going to search through that and remove the first instance of that item in your list. So when I do that, it removes flour, and now when I type in groceries, you can see flour isn't anywhere in here. Let me do this. I'm going to add flour in here twice. And let's do it 3 times. And let's print it out. You see I've got flour in there 3 times. Now watch what happens when I do the groceries dot remove flour. All right. I've removed flour. But let's print it out. You'll notice flour is still in there twice. Because what it does, what groceries, or what the remove method does, is it's going to search through your list, and it's going to remove the first instance of that item in your list. So if you have more than one, it is going to leave the others in there. All right. So another thing you might want to know is, well, how do I know if there's any of those items left? You can do this. Flour in groceries. And notice I get true. Okay, we're actually going to use this in just a minute, this concept in just a minute in the little program that we're going to write, which is going to be a program to keep track of a grocery list. So anyways, I use the name of the item in groceries and it returns true. So I can use that return value in, like, say, maybe an if statement or a while statement to do something while or if flour is still in groceries or the item is still in the list. Let's see what we were talking about. I'm getting distracted. Let me look at my notes here. Oh yeah, removing items. So that's one way to remove items. There's another way, and that's using the del command. So let's see here. Yeah, okay. So I could do this. I could say del, D-E-L, for delete, and the name of the list, like groceries, and then just the element number. Okay, like let's see here. Well, heck, let's get rid of Coke. That should be element number 0, element number 1, right? Element number 0, element number 1. So let's get rid of that. And now let's print out our grocery list again. And notice it's gone and everything was shifted to the left. So Coke is gone and we got eggs. Let's see what else we want to talk about. Oh, yeah. So when you are doing the remove, all right, you need to make absolutely certain that the item you want to remove is in that list. For example, we've already removed Coke. Let's say I try to remove it by name again. Okay, groceries.remove Coke. I get a value error. Tell me that it's not in the list. X is not in the list, and that's where that where is it? That's where this comes in handy. And we're going to use that, like I said, in the program we're going to write in just a second. Is this in our list? And then you can say, okay, it is in the list, so go ahead and, remove it. Let's see. Anything else I want to talk about? Oh, yeah. I want to talk a little bit about list slicing, and I'm not going to talk a whole lot about it. I think I forgot to mention it at the beginning. This tutorial is not going to make you an expert at Python or Python list. It's really just a quick introduction to list in Python. And there's still a lot left to list in Python, but this will get you started. Okay, so slicing. Let's print out our list again. All right, groceries. So there we go. Bread, eggs, hamburger, hot dogs, hot dog buns, hot dogs, mac and cheese, milk, vegetables, flour, and flour. Once again, let's remove flour. All right, groceries.remove flour. And now we've just got it in there one time. Okay, let's talk about list slicing. Let's say I want to get to certain items in the list, multiples, or I want to make a new list. Heck, let's do this, sublist. And this is just a variable name. Okay, this is just a variable name. I'm making it up on the fly. Probably not even a good variable name, but it's a variable name equals groceries. And let's say I wanted this sublist to just have eggs. No, let's just say hamburger, hot dogs, and hot dog buns, or hamburger, hot dog buns, and hot dogs. I can go from 0, 1, 2, okay? Item number 2 on the list, and then notice the colon, 2, 2, 3, 4, and I know this is about to get weird. I actually have to go to 5, and I'll tell you why in just a second. So that's going to pick up everything from 2 to 5 and put it in this new list that I've got called sublist. And now let's look at what sublist looks like. And there it is, hamburger, hot dog, buns, and hot dogs. So I sliced the list. I said, hey, give me a new list, and I only want elements 2 through 4. So there's a couple different ways you can think of this. It's up to you how you want to think of it, but you're always going to get the first element that you specify. So this is element number 2, 0, 1, 2. And you're going to go to one short of this number right here. So we're going to get 2 to 4. 2 is element number 2, element number 3, and element number 4. So we're going to get hamburger, hot dog, buns, and hot dogs. However, there's a better way to think of it. Think of it as this right here before bread, okay, is a 0. And this break right here between bread and eggs is 1. And then this is 2. and this is 3, and this is 4, and this is 5, and this is 6, etc. That I guess area between the elements. And so what this really means is give me everything from 2 to 5. Once again, 0, 1, 2. So we're going to start here. And we're going to go 3, 4, 5. So that's everything from 2 to 5. I know it's a little bit confusing. It's one of the things you got to get used to in Python, but I think once you get used to it, it's actually fairly easy. So you can either think of this as you get one less than the element that's maximum, okay? Or as most books on Python will teach you to do, take a look at the actual beginning of each element. So this is the beginning of element 0, element 1, the beginning of element 2, 3, 4, 5. And so you basically want everything from 2 to 5. So 0, 1, 2, 3, 4, and we're going to end on 5, okay? We're going to end on 5. And so we get hamburger, hot dog buns, and hot dogs. Okay, before we get to our example, let me see if I left anything out. There's a couple other things real quick. I've already showed you that you can get the length of the list, length of groceries, in case you wanted to know how many items are in the list. You can also do max. Max groceries. That's going to give you the highest. Let me print out groceries here. There we go. All right. Then let me sort it real quick. Okay. Now let's go back to max. It's going to make a little bit more sense here. After I sorted it, vegetables is the highest item in the list. And then there's men. I can do the same thing. Oh my gosh. I got a second time I did that in a row. All right, there we go. So it's min, max. I think that's all I really want to show you in this tutorial. There's other stuff you can do, and lists are incredibly powerful. And once you get the basics down, I implore you to go take a look. There is one other thing. I told you that lists can actually hold more than one type of data. In this case, we use nothing but string values, words basically. But if I wanted to, I could do groceries.append, and I can give it the value 3.141159. Okay, and so now when I print out groceries, you can see it's in there as a number. So there's a bunch of strings, then a number, etc. So and list can even hold other lists. That's kind of an advanced topic. I'm thinking about doing a whole little tutorial about that, because the next game we're going to be writing here on Coding with Colt, called Hunt the Wumpus, is going to use a list of lists to keep track of things. But anyways, I think we now know enough that we can come over here and we take a look at this little example that I've got. And I'm using a thing called Genie. I love Genie as a beginner's what's called IDE, or Integrated Development Environment, just because it's incredibly simple. It doesn't get in your way. One of my I guess main philosophies is that the tools that you use when you're learning to code should not get in the way of your coding. And so I think sometimes when we use really incredibly high-end, professional, fancy integrated development environments, that oftentimes those tools kind of get in our way of learning. And Genie is awesome because it's kind of a bare bones development environment. So let's take a look at this program real quick. It's called, what did I call it? List example, but really it's it's to keep track of a grocery list. So let me run it. And what it does, here we go. Your current grocery list is as follows. You currently have no items in your list. What would you like to do? You can either print the list again, so that's number one. Your current grocery list is as follows. Now, we can add items, we can remove, we can sort the list, we can erase the list, or we can quit. So let's add an item to our list, and let's add bread. All right, your current grocery list is as follows. Bread. Let's add an item again, milk. And then let's add an item again, milk, bread, eggs. Okay, so there we go. So we got bread, milk, and eggs. Let's remove an item. And we can remove by name or by position. Let's remove by name. Item to remove. Let's remove milk. And so now current grocery list is as follows. We can let's sort the list. It's already sorted. Let's add something else. We don't need milk, but we need, I don't know, ketchup. Okay, so now it's still sorted. Let's add another item to the list. Bread. Let's add milk back in, and it's actually still sorted. So, anyways, if I did that, it would sort the list for us. And then I can also remove by position. So I can come over here, remove by position, press P. Item number remove. Now watch this. If I do item number 5, it's going to tell me, hey, sorry, that item doesn't exist. And then it's going to go back to the beginning. So let's just quit. That's enough of it. And in reality, you can use this program to keep track of anything you want. I did groceries, but you can use it to keep track of anything you want. All right. Up here at the top, I did import time. Okay, so we're going to need the time module because we're going to do a little pausing here and there. And then I want us to ignore these functions here. We're going to get to those in just a second. Where I really want to start explaining the program is right up here at line number 57, because this is where the bulk of what happens is happening. All right, first thing I do is I make a couple variables, one called running, one called quit. I set running equal to 1 and quit equal to 0. And then this little program state, I set it equal to running. All these do, it's probably overkill for what we're doing here, but it's keeping track of the program state. You'll see why in just a second. And so program state is just a variable, and we're going to set it equal to running, which running is equal to 1, so program state is going to be equal to 1. Then here's where we make our empty list. We're going to start an empty list, call it groceries. Groceries equals, and once again, the open and close brackets. And that's going to make an empty list. Then we go into the bulk of what we do, a big long while loop. And we say while program state, remember that variable program state, equals, remember double equal sign means comparison, equals running. In other words, while program state is actually equal to the number 1, we're going to just do all this over and over and over again. There's going to be a spot where we're going to set program state equal to quit. And then when it comes up here and tries to make this test, it will fail and exit out and say thank you and enjoy your grocery shopping. All right. So the first thing we're going to do in our loop, and notice once again everything is indented in the while loop. So what that means is everything in here, everything that's indented one level, there we go, one level, that's what I'm looking for, belongs to this while loop. Is going to be executed over and over and over again until the while loop quits. All right, first thing we do is we print our grocery list. So let's go look at that function. All right, and I've got these functions collapsed, and I'm just going to hit plus. Okay, print grocery list. So what happens is, and if you're not familiar with functions, when it hits this right here, print grocery list, it's going to say, hey, I have no idea what that means, but have they written a function called print grocery list? And sure enough, we have right up here. And I'll do a whole video on functions in just a bit, but right here, we always start it with DEF for define or define function, the name of the function, and then notice this colon right here. Okay, that's important. And then we indent everything we want to occur or run inside that function. So we're just going to print out, hey, your current grocery list is as follows. And if you don't know what these /ns are, what they do is they just print a carriage return. A new line is to give us some spacing and make things look a little bit neater. Now, here's what we do. We say if the length of groceries, our list, if it's equal to 0, just print out, hey, you don't have any items in your list. Sleep for 1.5 seconds, and then return. What return does is that when it hits return in a function, it returns back to where it got called from. So when it hits this return, let's say our length of our groceries is equal to 0. We don't have anything in our grocery list. It's going to hit this return, and then it's going to jump back down to here and do this next line right here, line 66. Choice equals menu. We're going to talk about that in a minute. However, if we do have items in our list, we get to A little complicated piece of code. It's not really complicated, but what we want to do is, and you know what, I might do this a little bit differently. In fact, I think I'm going to write that a little bit differently. Give me just a second. So you might be tempted. What we want to do is we want to print out each and every single item in our list, right? Every item in our list. And we also want to put the number or its index number there. So we might do this. Num equals 0. And then we do for item in groceries. And then we might do this. Print. Oh, you know what I'm going to do? I'm not going to make this num. I'm going to make it count. Because it's going to allow me to then just copy and paste this. And I'll explain this code in just a second. I know we didn't go over iteration, but we will in just a second. And then okay. So what we do is we want to print out our list, right? Each item in the list, but we also want to print out its index value, where it is in the list, 0, 1, 2. That way the user, when they go to delete an item, they can say, I want to delete item number 6 or item number 5 or whatever it is. But they've got to know that item number. So we're going to set a little variable. We're going to call it count. We're going to set it equal to 0. And then what this does is it iterates for the over the list. We say for item in groceries. What that's going to do is it's going to set up a loop. Okay, a loop. And each time through the loop, the variable item is going to get the value of the next thing in our list. So let's say we had a list and it was milk, eggs, and bread. The first time through the list, item is going to be equal to the word milk. And count is going to be equal to 0. So it's going to print out 0, colon, and groceries count. Actually, we could just do this. An item. There we go. That's better. And in fact, I messed it up over here too. It would have worked, but not a big deal. All right. So we print count. That's the number, colon, and then the item. Because remember, item each time through the loop is going to be equal to the next item in our grocery list until it gets to the end of the grocery list where the for loop will exit. We're going to sleep and then return. All right. Well, let me run this just to make sure it's working. Make sure I haven't put any errors in here. All right. You currently have no items in your list, so let's add an item. Let's add milk. And there we go. It's working. Let's add bread. There we go. So it's working. All right. Let me quit. 6, quit. All right. Press return. I always forget to exit out of there. Okay. So this works, and I hope you understand how it works. For every item that's in our grocery list, we're going to print the variable count, which initially count is equal to 0. Okay. We're going to print the colon, and then we're going to print what the item is. Now, this is just a variable. I could have called it anything. I could have called it for every, I don't know, grocery. And then I would just change this to the word grocery. This right here is really just going to be a variable that's going to hold the next item in the list. I could have called it anything I wanted following standard Python naming rules. But I just called it item. Okay? There we go. And then we're going to increase count by 1. That's what plus equals. This is a shortcut. I could have said count equals count plus 1. I could have done this. Count equals... it's just plus equals is a shortcut for doing that. It's a really common pattern in all of programming. And so this just says, hey, add 1 to this variable that's right here. I could have did plus equals 10 or plus equals 50 or whatever it might be. It will add this value to the value on the, or to the item on the left. Okay, now here's the deal. It turns out that this pattern right here is so common in Python that there's a way to do it a little bit easier, using something called Enumerate. And that's what I did here. Even though I kind of sort of messed it up. And so what we do is we say, hey, for count, it's going to be the number through the loop, how many times we've gone through the loop, comma item. Once again, that's going to hold the item. And I could have called these variables anything, once again, anything I wanted to. For count, comma item, and enumerate, okay, notice the color. This is a Python function, and then the name of my list. So what's going to happen is every single time through this loop, item is going to get the actual item that's in the list, and count is going to be the number of times that we have gone. It's going to be essentially the index number of that item. And then I just do the same thing, print count, colon, item. And then just before the end, I do time.sleep 1.5. And then when it gets down to the end, okay, there's nothing else to do. It's going to jump back to here. And it's going to say choice equals menu. Let me collapse this. All right. So after we print out our list, it's going to come over here to choice equals menu. And here's what happens here. Once again, we're going to jump up to here to this function named menu. And let me increase it. Okay. So what we're going to do is we're going to hold a choice number. The user is going to be able to put in 1, 2, 3, 4, 5, or 6. And we're going to return. I'll get to what that means in just a second if you're not familiar with Python functions. We are going to return the choice number that the user has selected. And we're going to assign that to this variable right here, choice. Now, I debated a lot when I was writing this whether I wanted to use the same variable name here as I did up here, because it can be confusing. Here's what I need you to understand. This value here, this variable choice, is completely different from this variable here, choice. They're two totally different variables, because this choice right here is a local variable to this function. Okay, this value right here, choice, only exists inside of this function. Whereas right here, this one, okay, exists outside of that function. It exists right here in what I'm going to call our main program area. Whereas this choice only exists inside. They're two different variables. So what we say is while choice equals 0. In other words, while the value of choice that we've set it equal to 0, while it's equal to 0, keep doing this over and over and over and over and over again. This right here is what's called a sentinel variable or sentinel value. It's we're gonna exit out of the loop once the user has chosen a valid choice. So what we do is we just print out the list of choices here, and then we say choice equals input. So remember, input is going to literally do that. It's going to get input from the user. So when this is run, the user is going to type in something, and that's going to get assigned to this variable called choice. So choice is going to equal whatever the user types in, whether they type in 1, 2, 3, 4, 5, 6, or hello, or whatever they type in, choice is going to get that value. Now, as programmers, once again, this is something I really kind of debated whether I wanted to do or not. We kind of need to validate that input. We need to find out, did the user actually type in something that we're expecting? Because if they didn't, it could crash our program. We're expecting a digit, right? 1, 2, 3, 4, 5, or 6. That's what we're expecting. So I said if choice dot isDigit equals true. So remember, input converts everything to a string. Okay, a string variable, in other words, letters and numbers. So what we do is we say, hey, if choice is a digit, if that's true, then do this. We're going to say choice equals int choice. What this does is it's going to convert choice, the value in choice that's inside of choice that it's holding, into an integer, into a number value, and reassign it back to choice, this variable. So now the variable choice is guaranteed to hold a number. Okay? But now we got to make sure that they picked a number 1, 2, 3, 4, 5, or 6. So we say, hey, if choice is less than 1, or if choice is greater than 6, set choice equal to 0. Say that is not a valid choice. and continue. What that means is, hey, go all the way back up to the while loop. So go all the way back up to the while loop. And because we reset choice to be 0, choice is still going to be equal to 0, and it's going to print all this out and do it again. It's going to get input, assign that input into the variable that we've called choice, check to see if choice is a digit, and if it is, it's going to then convert choice, the string value, into an integer and reassign it back. And then we're going to see, are you less than 1 or greater than 6? But here's the deal. If you are 1 to 6, okay, it's going to skip all of this and go over to here. And we're going to return choice. Okay? So what this return choice does, choice is going to hold a number 1, 2, 3, 4, 5, or 6 by the time we get to here. And what that's going to do is it's going to return that value to the calling statement. We're going to take a look at that in just a minute. The other thing I wanted to say is if choice is digit equals true, if this fails, okay, if this is false, let's say they've typed in the letter A or B or hello world, whatever, it's not a digit. And so that means it's going to jump to here. Else print that's not a valid choice and go back up to the top. All right. So now, this is that value. Remember we said return choice? It's going to be assigned into here. And I could have called this variable anything I wanted. It didn't have to be choice, okay? Did not have to be choice. I could have called it anything. I could have called it num. I could have called it anything. And it's going to hold whatever value was returned right here. It's going to be 1, 2, 3, 4, 5, or 6, okay? Let me change it back. Whoops, Control Z. Oops, Control Y. Getting ahead of myself. Okay. So now choice is going to hold number 1, 2, 3, 4, 5, or 6. All right. If it's a 1, that means print the list again. And we don't actually need to check for that, because what will happen is if this falls through and nothing else gets, and it doesn't execute any of these, it's going to go back up to the top and print it. So that's fine. But if they entered a 2 meant add an item. All we're going to do is ask them for the name of the item to add. And we're going to do groceries.append item. I'm going to skip 3 for just a second. If they entered a 4, well, 4 was sort. So we're just going to grocery.sort and then go back up to the top and do it all again. If it's 5 meant clear out the list. And that's another easy one. We just do groceries equals nothing, open and close brackets, which will mean that, it's basically clears out the list. Nothing will be in the list. And then finally, if it's 6, that meant quit. We set program state equal to quit. So now when it goes back up to the top, program state is not equal to running anymore. It's equal to quit, which is 0. And so it's going to quit. Basically, this test failed. Whoops. Okay, there we go. This test fails, so it's going to skip everything in the while loop, go down to here. Now, you might be asking yourself, well, why didn't I just put all the remove items stuff in here? You'll see that remove items quite large because we got a bunch of stuff that we have to check for. And in general, it's not good to put all that logic inside of the if statement. My general rule of thumb is if I can accomplish, okay, what's supposed to happen inside the if statement in just a couple of lines of code, I'm going to put that stuff inside the if statement, like this right here or this right here. That's easy to read. It makes sense. But if it's more than that, I'm going to make a function for it. Otherwise, it gets very confusing to read. So if choice equals 3, that means remove item. We're going to hop up here to our remove item function. See if I can fit it all on the screen. I can. Okay. So first thing we're going to do is we're going to say, do you want to remove by name or position? And we're going to get their choice. Remember, once again, this choice exists, this variable exists only inside this remove item function. And we're going to convert it to uppercase. The only reason is that they can enter in a uppercase N or lowercase n, or and it just makes it easier because now I can just check if choice equals uppercase N, meaning they want to do it by name. Okay, so if choice equals uppercase N, okay, we say item equals item to remove. Now remember, This is super important. If you remember back when we were talking about here, if the item is not in, okay, if the item is not in the list, the item is not in the list, we're going to get an error, and that's going to halt our program. So we need to check and make absolutely certain that that item is in the list. So if they enter in, okay, it means remove by name, we're going to say item equals input item to remove. So what's going to happen is item is now going to get whatever they type in. They might type in milk, bread, eggs, whatever. But then we're going to check if item is in groceries. Okay, if item is in groceries, if that's true, then we're going to go ahead and say groceries.remove item because we're safe. We can do that. Else, okay, else if that's not true, we're going to do print, sorry, hey, that item doesn't exist. We're going to sleep for 3 seconds. Okay, we're going to sleep for 3 seconds, and then everything else is going to execute. Now, if I wanted to, I could actually make it a little bit easier, what I think is easier to read. At this point, we're ready to exit out. Okay, we're going to jump out of the function and go back to here. Okay. Else, if it equals P, okay, they want to remove by position, that's pretty easy. We're just going to say, hey, what's the item number? Okay. And we're going to convert it to an integer. Now, in reality, I probably should have done the is digit thing. In fact, that's something that you can change, something that you can figure out how to do. Because if they don't enter in a number, bad things are going to happen in a program. I'll show you. But anyways, so if choice equals P, we want to remove by position. We say item equals input, item number to remove. They're going to type in a number, we hope, and we're going to convert it to an integer. That's what that does. Because remember, input automatically makes everything a string. So even though they might enter in the number 7, it doesn't look that way to Python. Okay, it doesn't see it as a number. So we're going to convert it to a number. And then we say, if the item is less than 0, okay, because they can enter in -7, and that's not going to make any sense. Or if it's greater than or equal to the length of groceries. Now remember something. Okay, let's say we've got 5 items in our list. Okay, we got 5 items in our list, but remember we start at 0, so it's going to be 0, 1, 2, 3, or 4. So if they say they want to remove item 5, that doesn't make any sense. So we want to check and make sure that we're not greater than or equal to the length of groceries. And if they do, we're going to print, sorry, that item doesn't exist, sleep for 3 seconds, and then it's going to drop down to the bottom and return. And in reality, it might be easier to read as a programmer. We're going to return. We're going to hop out of this function because, things have gone wrong. Okay. Else, okay, in other words, if the item is a valid item, it's not less than 0, and it's not greater than the length or equal to the length of our groceries, we're going to use del grocery item. Okay. Finally, else, we're just going to print, I don't understand what you want me to do. Okay. So that's pretty much the whole program. And whoops, let's collapse that right there. So let's run it. Make sure none of the changes I made broke stuff. Okay, let's add items to list. So once again, milk, bread, eggs, I don't know, milk, bread, eggs, hot dogs. All right. So once again, if I enter in 1, it's just going to go back up to the top of that list, do everything again. So we're going to get our list and our options. I can remove from the list. And let's test that out. Do you want to remove by name or position? So I'm going to remove by position. But watch this. If I enter in S, it's going to crash on us. So that's something that you out there can fix. But anyways, the program works. I called it grocery list, but in reality, it can be used to keep track of anything. So anyways, list, as I said, are probably one of the single most powerful parts of Python. And this is just scratches the surface of what you can do with Python list, and I encourage you to start writing programs that use list so that you can get used to it. I'm going to be showing some really cool programs here in the future, and they're all going to use list, so it's very important that we understand list. And in fact, I've got a little game that we're going to be writing here soon called Hunt the Wumpus that is going to use two-dimensional list, or lists of list, and I debated whether to put lists of list in this video. But I think if you can understand this and what we're doing with list, that you'll be able to understand list of list when we take a look at Hunt the Wumpus. So once again, support the channel if you would. Hit that subscribe and like button. And if you got any comments or questions, stick them down in the comments. Thanks a lot. Today was a great day to learn to code, and I'll see you next time.